Okay, today I'm going to talk to you about the Reactivity Series. Underneath is an example of the Reactivity Series. All that it is a list of different elements. The most reactive is at the top, and as we go down we get less and less reactive until we get down to the bottom and we have the least reactive elements near the bottom. Now, you don't need to learn the Reactivity Series, you just need to be able to apply knowledge about it. Now, the reason why I've done carbon and hydrogen in a different colour are these are non-metals. All of the rest on here are metals. It's just important to know these because carbon, it comes in when we think about reduction with carbon, and hydrogen we need to know when it comes to reactions with acids. So, is a bit of information we need to know is about oxidation. Now, oxidation means a reaction with or addition of oxygen. So, the elements at the top, for example, potassium is very, very reactive. So as a result, potassium is the easiest to oxidize. It oxidizes very, very readily. That's why it's right near the top. And as you go down, it becomes less and less easy to oxidize, right until you get to the bottom at gold, which is the most resistant to oxidation. Okay, so we can also use reactions with acids and with water in order to learn more about the Reactivity Series. So let's imagine I've got 5 different test tubes. Each of them contains hydrochloric acid. So we're going to see what we'd find if I reacted each one with an acid. So we're looking at reactions with acid. So when I add a metal and an acid together, I get a salt being produced and hydrogen gas. Now we can see this, and we can see the different reactivities based on the reactions with acid. So let's say I take something that's quite high up the reactivity series, something that's quite reactive, such as magnesium. If I take magnesium and I put it into my hydrochloric acid, so I'll just label 1 with HCl so we know that's hydrochloric acid, then we could see we'd have a very vigorous reaction. Remember, hydrogen is being produced when we react a metal with an acid, and we'll see loads and loads of bubbles being produced here. Now, the test for hydrogen is called the Squeaky Pop Test. Now, what you do is you hold a lit splint over the test tube, and if there's a squeaky pop, then we know that hydrogen is present. Now, this squeaky pop would be really, really loud. So we could test these with different metals. So the next one, let's say we've got aluminium there, which is 1 down the reactivity series. Then we'll have zinc here, iron here, and in the final one, copper. So what we'll find with each of these, let's say each of them is the same strength of acid, the same volume of acid, and the same mass of metal. What we should find is each one will have a slightly less vigorous reaction with hydrochloric acid. So with this one, it will produce hydrogen at a very quick rate. There'll be a loud squeaky pop and a large one. Then this one would have a slightly quieter squeaky pop and slightly fewer bubbles being produced at a slightly slower rate, and so on. Until we got to copper, which will have no reaction at all. The reason why copper does not react with hydrochloric acid is because if we have a look at the reactivity series, copper is below hydrogen. So as a result, it does not react with hydrochloric acid. Now, it's not just acids that metals can react with. Are really, really reactive metals, such as potassium and sodium, these ones up here, they're so reactive that they react with water. Now, I'm just going to show you an example using potassium. So potassium plus water makes potassium hydroxide and hydrogen. So I'll just balance that quickly. So again, hydrogen is being produced. So again, we could use a squeaky pop test to test for this. Now, some of these, so zinc and iron, for example, they don't react with water. They're not reactive enough to react with water by itself, but they can react with steam. So we have a simple experiment to do that. All you have is a boiling tube like this with a bung in the end, and you have some mineral soaked in water, mineral wool soaked in water. So that's wool soaked in water. And in the boiling tube, you might have that bit of iron. So this is this bit here. Now, when you heat up the wool, the water evaporates. It travels over the iron, reacting with the iron, in order to produce hydrogen. So if you light the end, it should be able to light. So that basically is the reactivity series. Most reactive at the top, least reactive at the bottom. When you test them with acids, there'll be a more vigorous reaction and a louder pop with the Squeaky Pop Test when you test higher up the reactivity series. At the very top, they do react with water. Otherwise, they're a little bit lower down. You'd have to react them with something like with steam instead, rather than just cold water. And that's the reactivity series. Thank you very much.